Okay, so it was 4, x to 1/2 of 1/1/2 plus c. Flip, we get 8. This is the square root of x plus c. I'm plugging in the point when x is 1. Y is -5. -5 equals 8 plus c. Move 8 to the other side, -13. I have to put it in. 8, the square root of x minus 13. This is the only function, unique function, whose derivative is this, guaranteed, and passes through this point. There is no other function. Okay, now we're going to use a fancy notation. That's my page 8. So I don't like the order in which this book presents the material, because when I present this notation, I start slowly with the algebra and some explanation, but they're reversing the two sections. So I'm going to do it the way they presented it. So the word sum has an important meaning in calculus. And we were discussing in section 4.2 more about it. It should have been the other way around. But so what are we trying to sum? We're trying to add areas. I don't want to jump into the symbol without explaining a little bit, and more will follow in 4.2. So if we have a graph, so let's say this is a graph of a function. If we determine the area under this graph, area under f of x, we get, if this is velocity, we get, if we determine this area, we will get the total distance. So notice that this is the derivative basically. If I'm given the graph of the derivative, or if I have the graph of the derivative, or if I don't have the graph, but the idea is, if I determine the area under the graph, let's say between 0 and 10, this area is nothing else but the total distance between the beginning of the trip and the end of the trip, let's say over, as my example, over 10 hours. So in order to determine these areas, we have to divide the area into small rectangles and add those areas. Adding. By adding areas, we are summing, in other words. We are using the sum. So this letter is not the best form of the sum, right? It represents the sum, but it's not a convenient notation for what we are trying to do. We are going to stretch this letter, and we're going to use it, and we're going to call it indefinite integral. But it's the same thing with the most general antiderivative. As I promised, we're going to use the same thing. We're going to do exactly the same thing. We're going to be given a function, and we're going to be asked to determine the most general antiderivative, not unique, the most general antiderivative. But we are going to use a fancy notation. It's not that fancy. It's the letter of the sum, so it's s, but it has to be stretched because just this little s will not do the job. But what follows here? What is this? So this symbol, called the indefinite integral, comes with something. That something is the differential of a function. of x dx, because it can be a derivative. So it's f of x dx. So okay, I can write f prime, and then the answer will be f of x plus c. But it can be anything. So the indefinite integral from f prime of x dx, which we know is dy, gives us f of x plus c, the most general antiderivative. So you can say, why do I need this fancy notation? Why can't I just stick with the most general antiderivative and it's good enough? True. I would say yes. But you will see what happens in 4.2 when we're going to continue our investigation of this. So that's why we need to understand this notation. Like we had in the past, we needed to understand this, and we needed to understand this, although they are the same. In certain situations we use this, in other situations we use this, but they are the same. And from here, dy, if you cross multiply, that's what you get, f prime of x dx. So everything is related. All these things are related. So coming back to this sum stretched s, so the indefinite integral of a function dx will give us this. So now let's see how this works. There is nothing else, it's just a different notation. So we can choose anything you like from 5 all the way to 46. So let's start easy. Okay, let me choose the first one. Let's say 9. Nothing new so far. It's just a different notation. The indefinite integral from 2t squared plus 5t minus 3 dt. Notice something very important. If the function is in t, I cannot have dx. I have to have dt. If the function is in x, I cannot have dt. I will have to have dx. So you don't even have to look at these two. They have to come together. This and this. So the indefinite, which is a sum of areas, not for the indefinite. You'll see what happens in 4.2. So this is s, but stretched. So the indefinite integral from 2t squared plus 5t minus 3 dt is the most general antiderivative, plus c. Copy 2. I need a function whose derivative is t squared. A function that we differentiate to get t squared. Please. Yes, I heard t to the third. That's it, plus. 5 has to stay. I need a function whose derivative is t.
Is it t2 over 2?
Excellent. Minus, I need a function, 3 has to stay. I need a function whose derivative is 1. That's it. Done. Just a different notation. The indefinite integral from 2t squared plus 5t minus 3 dt is 2/3 t cubed plus 5/2 t squared minus 3t plus a constant c. That's it. We don't have to write anything else. Feel free to choose anything you want, let's say from the first set till 32, and then we'll look at the next set. Anything you want. This is it. It's just a fancy notation, but we need it for later. Number 17, perfect. The indefinite integral from dx over x to the fourth. Awesome, very good pick. Great job. Good. I refuse to work with this, but I like to work with this. Change this function into something that I can work with. How do we write 1 over x to the fourth in a different way?
X to the fourth is negative 1/3.
I'm not calculating anything. I'm just replacing 1 over x to the fourth to something that it equals to. So I can work with it. Right now I cannot work with that.
X to the negative 4.
Excellent, thank you so much. Good. So now, of course, I'm going to have to add c because I'm looking for the most general antiderivative. So I cannot ever forget c. I need a function whose derivative is x to negative 4. Same rule applies no matter what the power is. A fraction, a negative number, a positive number, we don't care. The rule is the same. Stays the same.
X to the negative third over negative 1.
Brilliant. You added 1 to the power and you divided blindly by the same thing. We don't even have to calculate anything. So now I can change this in that form. Perfect, awesome. Any questions on this problem? Perfect. Let's choose anything else. It was a very good pick. I would like to choose 19. So this was 17. Let me choose 19 and then you choose the next one. The indefinite integral from 10 over x dx. Good. 10 can wait outside. It's a constant. It's multiplied by 1 over x. It's like you ask, what happens to this 6? It's here. What happened to this negative 4? It's here. Nothing happens to those constants. They are waiting outside patiently. Good. So now the question is, which function prime is 1 over x? Of course, plus a constant c. There is only one function that we differentiate and we get 1 over x. Which function from our past we differentiated and we got 1 over x? There is
Negative x.
Nope. There is one specific function, only one, that we worked on or we worked with quite a lot, whose derivative is 1 over x. Anyone, please? Anyone remembers what function? When we differentiated it, we get 1 over x. But this is important for tomorrow. We should know this. This is a major formula. No one remembers the derivative of a function that is 1 over x?
Negative 1 over x squared.
No.
Is the natural log of x?
Absolutely, natural log of the absolute value of x. When we differentiate natural log, we get 1 over x. So please remember that. This is a very important formula. Okay, should we look at another problem, or can we look at a word problem? You can choose anything else. Oh yeah, let's choose something with E. Anyone would like to choose, or I will?
$32.
32. Okay, very good. The indefinite integral from 2500 e to negative 0.075x dx. Perfect. Great job. Yes, this is multiplied. You can wait outside patiently. So 2500. Which function prime is this? We used the same thing a minute ago with power 2, with power x, I'm sorry, with 2x and with 7x. It's exactly the same thing, it's the same formula. No changes, no difficulties. What do I write?